Hi everyone, this is the second chapter of my Flutter REST API crash course where you will learn how to build this coronavirus tracker application. This chapter is available for free here on YouTube and you will be able to find the full paid course on this page at courses.codewithandrea.com. So here are all the videos for the second chapter of this course. Now that we have a good understanding of the REST API that we are going to use, we can start thinking about how to build our coronavirus tracker app. And I think a good way of doing this is to figure out what kind of architecture we need. So what I have here is a general diagram of what we are going to build. As you can see at the top, we have a web server that we will talk to when we make requests to the endpoint 2019 API. And since we want to build a Flutter app, we are no longer going to use the REST client to make requests, but instead we will use the Dart HTTP package. This will give us a way to make HTTP requests directly in Dart and process the incoming responses, so that we can extract the data that we want and show it on screen. And if we really wanted to hack a quick solution together, we could build this dashboard as a single page widget that uses directly the Dart HTTP package. But this is not an approach that leads to maintainable code, and if you have seen some of my previous tutorials, you will know that I care about best practices and good app architecture. So in order to build this application, we will start from the top of this diagram and we will build an API service class that will give us a clear domain-specific API that we can use in the rest of the app. And we will see the benefits of this as we make progress. The API service class will be completely pure in the sense that it will not hold any state. However, we will need some state to work with this REST API because we can only make requests to the existing endpoints once we have an access token. For that purpose, we will create a new class called data repository, which will keep track of the access token, and it will be smart enough to refresh the access token when needed. Not only that, but I should remind you that this API gives us access to the data that we need with 5 different endpoints. And this means that in order to show the data that we see in this page, we had to make 5 separate requests. So the data repository class will also take care of combining together the asynchronous responses from the different API endpoints and making all the updated data available at once. As we make progress and build our app following this architecture, we will also learn about error handling and data caching, and we will see which parts of the code are best suited to deal with this. Finally, we will see how to build this UI by creating reusable widget classes. So what I have represented here as dashboard is actually a widget tree that is built by creating smaller specialized widgets and composing them together. Okay, so hopefully this video has given you some insight about how we will build this app. And in this section, we will focus specifically on learning how to use the Dart HTTP package so that we can build this API service. Okay, so let's continue on the next video. In the upcoming videos, we will see how to create the API service that is needed to retrieve the access token and the endpoint data. But before we do that, there are a couple of setup steps that we need to do. The first one is to install the HTTP package, which can be found at this page on the pub.dev website. This package is quite simple and lightweight, and you can use it if you need to make HTTP requests in your Flutter apps. So let's go ahead and copy the name and version number, and then we can get back to Visual Studio Code and open the pubspec.yaml file, which will list all the packages that we will use in this application. And then we can locate the dependencies section, and just below this line, we can paste the package name and number, and make sure to add a colon character in between, like this. By the way, if there's a newer version of this package by the time you watch this video, feel free to use it. And after we have done this, we can save the file, and if you are using VS Code, this will automatically install this for you. Or alternatively, you can press this icon to get the packages manually. And now that this step is done, we can use the HTTP package in our project. Okay, so let's continue on the next video. In this video, we are going to create a new file to hold the API key that we need when we request an access token with the REST API. For this purpose, we can open the lib folder, and inside here we can create a new folder called app. And inside here we are going to create yet another folder called services. And in here we can create a new file called API keys.dart. like this. And then we can create a new class called API keys. And inside it, we can add a static string encov sandbox key, and we will initialize this to an empty string for now. This represents the sandbox key that we use when requesting an access token. If you remember, we have saved this inside the VS Code folder inside this settings.json file. So we can just copy this authorization key from here, and then we can paste it in here, like this. And since API keys are very sensitive information, we don't want to commit them to version control. So inside this folder, we can create a new file called gitignore. And inside it, we can write API keys.dart, like this. And then we can save this file, and we can see that the API keys.dart file becomes blue to indicate that it will not be committed to version control. And we can make sure to save the API keys file as well. Okay, so we have now completed our initial project setup. And before we move on, I want to mention that at the end of each lesson, you'll find a zip file containing all the latest code. And in addition to that, you can find the entire source code on GitHub at this page. And if you open the branch drop-down over here and select tags, then you can also find the code for all the lessons. So if you get stuck or your code doesn't work as you make progress, this gives you a way to get back on track. Finally, I want to mention that from the next video onwards, we will be writing a lot of code. And because this course is fast-paced, my main focus will be on explaining important concepts rather than spending a lot of time typing. So as you follow along and repeat my steps, you may find that sometimes your code has errors. For this reason, I highly recommend that you install this Visual Studio Code extension called Error Lens. And the great thing about this extension is that it shows hints, warnings, and errors as you type, making it much easier to fix any syntax problems in your Dart code. And you'll see this extension in action in all the upcoming videos. Okay, so let's continue on the next video. In this video, we are going to create a new API class that will give us access to all the URLs that we need to make requests with the HTTP package. And just to be clear, when we talked about app architecture, we said that we would create an API service class so that we can make requests with the HTTP package. So if we wanted, we could store all the URLs inside the API service class itself. But I think it is better to have a separate API class just to list the URLs. And one reason I want to do this is that we can create separate instances of the API class for sandbox and production, so that the API service class doesn't have to worry about which environment we are using. Okay, so let's see how this is going to work in practice. Inside the app/services folder, we can create a new file called api.dart. And then inside here, we can add a new class called API, like this. And then we can add a final string API key. And we can generate a constructor for this class and move it to the top. And I also want to make this a named parameter and make it required as well. And this will work if we import foundation.dart. Next, I'm going to create a factory constructor, which will be a little helper that we will use when we create instances of this class. I'm going to name this api.sandbox, like this. And this will return an API object using the sandbox key that we have defined in the API keys class. And to make this compile, I can import API keys.dart. After that, I'm going to create and initialize two static variables. These are initialized to the same values that we can find in the API console for the encov 2019 API. We will use these variables in a second, and for now I'm going to define a new method which will return a value of type URI, and it's going to be called token URI, like this. And we can use this to return a new URI object with the following arguments. And in case you're wondering what an URI is, well, URI stands for Uniform Resource Identifier, and it is used to uniquely identify resources on the web. And according to the Dart documentation, the URI class provides functions to encode and decode strings for use in URIs, which you might know as URLs. And we can create URIs by providing the arguments that we have specified over here. So what we are doing here is to define a resource identifier that we will use to get the access token. And I think it's useful to show you what syntax we need to use when we create an URI. We start with HTTP or HTTPS, which is known as the scheme. Then we have a host, which is normally in this format. And optionally, we can specify a port number. After that, we have a path, which identifies the resource that we want from that host. And finally, we can add some query parameters, which are represented as 0 or more key value pairs. And if we wanted, we could have used just a string to represent the URLs that we want. But I feel that using the URI type is a better idea, because it gives us a better and safer API than the string class. By the way, given a URI, you can get the corresponding string URL by typing .toString. But we don't want to do this here, and instead the API service that we are going to build will take care of this. Okay, so let's continue on the next video. We are now ready to create the API service class that we have been talking about. We will use this class to make requests, and in this video we will focus on adding the code to request the access token. So let's move to VS Code, and inside the services folder we can create a new file called APIService.dart. And inside it we can add a class API service, and this will hold an instance variable of type API. So we can import the API.dart file, and we can also generate a constructor for this class, like this. Then we want to create a method that we can use to get the access token. This method will have a return type of future of type string, and we will name this getAccessToken, like this. Okay, so let me unpack this for you. Over here we use future to indicate that this method will give us a string value at some point in the future. The reason we need this is that inside this method we will make an HTTP request, which is an asynchronous operation. In other words, when we call our REST API, we can't expect the response to be available immediately, because our request needs to reach the web server and then the response needs to come back. So let's write the code to make our request. At the top of the file I'm going to add an import, and here I want to import the HTTP package from here. And just before the semicolon, I'm going to add a space and type as HTTP. If you're not familiar with this syntax, just bear with me and it will be clearer in a second. So let's get back to the method body, and here I can type final response equals await http.post, like this. And because here I'm using await, I need to remember to mark this method as async, like this. Now, post is a function in the HTTP package that we can use to make a post request. The first argument of this method is the URL that we want to use. So here we can type api.token URI.toString, like this. And what this does is to take the URI that is returned by our API object and convert it to a string. Now, in order to request the access token, we need to pass an authorization header, which is what we have done when we have defined our request over here. So over here, we can add a headers argument, and this takes a map of key value pairs. And in this case, we want to pass a key called authorization, and the value is going to be basic, and then we can add the API key using string interpolation. So this is how we can make the post request to get the access token. Before we continue, I want to explain a couple of things. The first one is that here I'm using the await keyword to indicate that this call should wait until the response is received. And because I'm using await over here, I need to mark this method as async. The other thing that we can see is that I've written http.post in order to make this request. And if I open the documentation for post, I can see that this is defined as a function inside this file, but this function does not live inside any class. And since post is quite a common word, other packages might also use it to define variables or functions. So we should find a way to prevent name collisions with other packages. And the way we do this is to use the as keyword to define some kind of namespace, so that every time we call functions inside this file, we need to prefix them with http dot. And in fact, this convention is even used in the example code for the HTTP package itself. In summary, in this video, we have seen how to use the HTTP package to make a post request, and we have talked a bit about futures, async, and await. By the way, if you're not entirely familiar with asynchronous programming in Dart, make sure to check out the links that I've included at the end of this lesson. So let's continue on the next video. In the last video, we have learned how to make an HTTP POST request. And in this video, we will see how to extract the access token from the response data. And if we inspect the documentation for http.post, we find that this returns a future of type response. And this means that after this call has completed, the response will be assigned to this variable. If you remember, when we first talked about REST APIs, we said that responses always include an HTTP status code and a payload. So what we need to do here is to check if we received a 200 response, and if that's the case, we can extract the access token. To do that, we can write a condition that says if response.statuscode equals 200, and inside the body we can get the payload. And because this REST API provides data in JSON format, we need to write this code to decode the data from the response body. Now, this JSON variable that I've used over here appears to be undefined. But in order to resolve this, I can import Dart convert, which is a file that contains some functions to deal with JSON data. Okay, so what this line does is to take the response body, which is a string object, and gives it as an argument to json.decode, which is a method that parses the JSON in the input string and returns a map of key value pairs. And how does this map look like? Well, if we go back to our HTTP file, we can send this request. And over here, we can inspect the response data. This includes an access token along with some other parameters. And because this data object that we have created is a map, here we can type final access token equals data and use access underscore token as a key. And then we can check if the access token is not null. And if so, we can return it. Okay, so this is all the code that we need to retrieve the access token if we have a 200 response. But in addition to this, we also need to handle the case where our request has failed. Now, our API service doesn't necessarily know how to handle errors. Instead, errors should be handled by the presentation and UI layers of the app. So in this case, one possible approach is to throw the response as if it was an error. And this means that the code that will call this method will be able to handle this with a try and catch block. By the way, we will soon test this code to see if it works, and I think it will be useful if we can print a console log over here so that we can see any errors that may happen when the application is running. So what this line does is to print the request URI along with the response status code and the reason. Okay, so let's continue on the next video. Now that we added the functionality to get the access token, it would be useful to test this and see if we can make this request while the app is running. So what I have over here is the app running on the simulator, and because we haven't made any UI changes just yet, this shows the counter application that is created with every new Flutter project. So in this video, we're going to make some small changes to this page so that we can show the access token when we press the floating action button over here. And just to be clear, we will not start building the final UI until later on in the course. So for now, our immediate goal is to test the APIService class. And to do this, we're going to open the main.dart file and we're going to modify the myHomepage state class. And we will make all our changes inside this increment counter method. So inside here, we're going to remove this call to set state. And instead, we're going to create an instance of APIService using this syntax. Final APIService equals APIService, like this, and we need to import APIService.dart in order to use this. And since the constructor of APIService takes one argument of type API, here we can type API.sandbox, like this, and we also need to remember to import API.dart. Then we can get the access token by typing final access token equals and then await API service dot get access token. And because we are using await here, we need to mark this function as async. Finally, we want to save this access token as a state variable and rebuild our UI. And to do this, I propose that we rename this counter variable to underscore access token, and we can change its type to string like this. and we can change the default value to an empty string. And just to be clear, here I've used the rename functionality of Visual Studio Code, which makes sure that when we rename this variable, it also gets updated over here. And now that we have this state variable, over here we can write set state like this. And then inside it, I'm going to use the arrow operator and assign my access token to the variable that I have created, like this. And just for clarity, I can also rename this function from increment counter to update access token. Okay, so with this change, I can now hot restart the application. And as we can see, the page is now empty. And once I press this button, I can see that the access token appears over here. And this happens because this method is called and the API service is created and it's used to get the access token. And finally, we call setState and assign it to this variable, and our widget is rebuilt as a result. And just to be clear, this is very temporary code, and we will delete this once we build the proper UI for our application. But for now, I just wanted to show you that our API service works. Okay, so let's continue on the next video. In the last few videos, we have learned how to use the HTTP package to request an access token inside the API service class, and we have checked that we can show it inside our application UI. Our next goal is to implement the code for getting useful data from the remaining endpoints. In other words, we need to extend our API and API service classes to support all these different requests. So in this video, we will start by adding this functionality to the API class. And since all these requests are very similar, I propose that we create a Dart enumeration to represent each of the possible endpoints. So we can open the api.dart file, and at the top over here, we can type enum endpoint, and inside it, we can add all these different cases. And what I want to do next is to define a map that we will use to associate each endpoint to the relative path that is used to create the endpoint URI. In other words, down here we can write static map of type endpoint and string, and I'm going to call this underscore paths, and then equals an empty map for now. And inside it, we can add the key value pairs that associate each endpoint to the relative path. And as you can see, these paths match the values that are listed in the NCOV 2019 API console. So how can we use this? Well, just like we created a token URI method, over here we could add a URI endpoint URI method which takes an endpoint argument, and this will return an URI object with the following arguments: a scheme, which is HTTPS, and then the host and port arguments that we have set over here, and we need to define a path argument as well. So over here I could add a static final string base path, which is set to the same common string that is shared by all endpoints. And here I could add a path argument, and I'm going to make it a string, and then I can use string interpolation and type in base path, and then I can add a slash, and then string interpolation again, and then within curly braces I can type underscore paths, and then within square brackets I can use the endpoint as a key. And by creating this path string like this, we always have the base path as a prefix, and at the end we have the string representation of the endpoint that is given as an argument. Okay, so this completes the implementation of our API class, and we can continue on the next video where we will see how to use this new endpoint URI. Now that we have added the endpoint URI method to our API class, we are ready to add a corresponding method to our API service class so that we can request and parse endpoint data. And just to get a better idea about what data we get in the response, we can open the HTTP file and run one of these requests with the REST client. And as we can see, here we get the number of cases as an integer value. And the same goes if we get data for any of the other endpoints. With this knowledge, we can go back to our API service class, and here we can add a new method which will return a feature of type int, and we will call this getEndpointData. and this method will take two named arguments. The first one is going to be an access token, and because I'm using the required keyword here, I need to import foundation. And the second one is the endpoint that we want to query. And since we will use the HTTP package to make an asynchronous request, here we can add the async keyword. Next, let's work out how to make the request that we need. So here we can type final URI equals API.endpoint URI with the endpoint that is given as an argument. And to make the request, we can type final response equals await and then http.get. And the first argument is going to be URI.toString, and then we need to pass some headers. So here we can create a map where the key is going to be called authorization, and the value should be better with the value of the access token using string interpolation. So this is all we need to get the response for a given endpoint. And like we have done before, here we can write if response.statuscode equals 200. And here we need to write the code to parse the response. Now, one thing that I'd like to point out is that there is a small discrepancy in the format of the response data for the different endpoints. To show you what I mean, I can open my HTTP file once again, and if I send a request for the number of cases, we can see that these are returned in the response inside a key called cases. However, if I send a request for the number of suspected cases, then the response contains the data that I want, but this time the key is called data. And in order to parse the response data correctly, I need to take this into account. So let's go back to the APIService class. And here we can create a new map that associates each endpoint to the JSON key that we will use to extract the data. In practice, this means that I can create a map that looks like this. This map has keys of type endpoint and values of type string, and each of these values represents the JSON key that we will use to extract the endpoint data. And now that I have this, I can write the code to parse the response. So inside this if statement, I can remove this comment, and instead I can add this line. So once again, I'm decoding the response body. But one thing that you could notice is that I have declared this data to be of type list of dynamic. So why is that? Well, if we run one of these requests once again and we inspect the response, we can see that this JSON payload contains a list with a map inside it. So if we want to parse this data correctly, we need to first extract the response body into a list, and then we can get the map from the first item of the list. So let's get back to the APIService file, and here I can add a defensive check that says if data.isNotEmpty, and then I can extract the endpoint data from the first item of the list. And here I've added this map of string dynamic annotation just for clarity. Then I need to get the JSON key that contains the value that I want, and I can do that by referencing the response JSON keys map with my endpoint argument. And finally, I can extract the data that I want by adding a final int result equals endpoint data with response JSON key as the argument. And finally, I can return the result if it is not null. Okay, so I feel that all the code that we added in the last few minutes was a bit complicated because we had to manipulate lists and maps so that we can extract the data that we need. And when writing code like this, it's easy to make mistakes. So in the next video, we will do a bit of testing to make sure that everything works as intended. In any case, this code takes care of parsing the response data if the status code is 200. But we also need to handle error cases. In fact, my editor is warning me that the function has a return type of future int but doesn't end with a return statement. So to handle errors, we will follow the same approach that we used before. So here we can throw a response so that we can notify the calling code that something went wrong. And we can also add a print statement so that we get a console log if our request fails. And with this change, we have completed the implementation for our APIService class. So let's continue on the next video where we will do some testing and wrap up this section. In the last video, we completed the implementation of our APIService, and this means that we can now use it to fetch the data from the various endpoints. In order to test this, we can go back to our main.dart file, and inside this class, we can add some logic to read some endpoint data and show it on this page. In fact, before we continue, I invite you to pause the video here and see if you can work out how to show the number of cases and deaths from coronavirus on this page. Okay, so let's see how to do this. First of all, we can try to call our API service to get the number of cases. And to do this, we can go over here and then we can type final cases equals await and then API service.getEndpoint data. And this is a method that takes two arguments. The first one is the access token, so we can pass the access token that we just retrieved over here. And the other one is the endpoint. So here we could pass endpoint.cases. And in order to show the number of cases, here we can add a new state variable. For example, we could call it int_cases, like this. And down here we can modify this setState call to execute more than one statement. So to do that, we can add curly braces, like this. And then we can say _cases equals cases, like this. And then we can scroll down, and here we can find the text widget that we use to show the access token. So what we can do is to copy this text widget and paste it over here. And here, rather than using the access token, we can use the cases number, like this. And one thing that I want to point out is that when this widget class is first created, this cases variable will be null. In fact, if I save and hot reload, I can see that here we get a null value. So what we want to do here is to only show this text widget if cases is not null. And just to be clear, this is a special if statement, which is called collection if in Dart. And we can use it to optionally add some items to a collection, like we are doing over here. And I should also point out that collection if was only introduced in Dart 2.3. And in fact, Visual Studio Code is warning me about it. And we can quickly fix this by opening the pubspec.yaml file. And here we can update the Dart SDK version to 2.7.0, like this. And if we get back to the main.dart file, we can see that the warning has now disappeared. So we can now hot reload our application. And now if we press this plus button, we can see that the number of cases is now visible. And if I wanted, I can show the number of deaths as well. To do this, I can add one more variable called int deaths, like this. And in order to get this value, I can copy and paste this call, and I can replace cases with deaths, and I can update this endpoint argument as well. And then I can also assign deaths to this new variable that I've just retrieved. Finally, I can scroll down one more time, and then I'm going to copy these lines of code and I'm going to paste them. And then I can update this condition and the text inside this widget. And just for extra clarity, here I could write cases and deaths, like this. And now I can hot reload one more time. And if I press the plus button, I can see that I get both the number of cases and the number of deaths. Okay, so let's continue on the next video. In the last video, we have verified that our API service works as intended. One thing that I want to point out is that here we are making a request to get the access token every time we want to show the endpoint data. I feel that this is unnecessary because we should only request the access token if the old one has expired. In any case, this is not code that should live inside this widget class. And instead, we should implement all the necessary logic on a separate class that we will call the data repository. In fact, I have said before that this code is temporary, and in the next section, we will see how to implement this properly. And before we do that, let's do a recap of what we have learned in this section. We started off by building an API class that gives us access to all the URIs that we need when querying the NCOV 2019 API. And then we have used these to build an API service that uses the HTTP package to make requests. And we have learned how to parse the JSON data in the response. And the good thing about this API service is that it gives us a clean, future-based API to get the data that we need. And all the code for making requests and parsing JSON lives inside it as an implementation detail. So really, the purpose of the API service is to abstract away all the implementation details and give us a domain-specific API that the rest of the app can use. And as a proof of this, we can see that getting the access token and the endpoint data is quite easy. Finally, I want to mention that this application doesn't need to work with complex data models that have a lot of properties. In fact, all this API does is to return integers or strings. And as you build your own apps, you might need some more complex logic to decode JSON data into your model classes. And if the data that is returned by your REST APIs is complex enough, you can consider using some code generation packages to simplify the process of parsing JSON into your model classes. For more information about this, you can check out the links that I've added at the end of this lesson. But as far as we are concerned, we already have everything we need to build this coronavirus application. So let's continue on the next section. We have reached the end of this section. If you liked this, you can enroll for my full course at courses.codewithandrea.com, which will contain additional content that I will not cover here on YouTube. If this has been useful, please like and subscribe for more Flutter videos. Thank you very much for watching, and I'll see you on the next video.